What's going on, guys, and welcome back to the channel. It's me, your host, Dr. Hint, and today we're taking a look at a study on stretching and cancer. But first, and always, please don't forget to like, comment, share, and subscribe, as that helps immensely with the algorithm and getting this information out to people. It's 2026 now, and I think people need to be more informed and educated about how this American labyrinthine Byzantine healthcare system works, about the studies that are coming out, in order to make better informed decisions for themselves. Now, today's focus is going to be on how stretching can possibly impact a specific type of cancer, specifically breast cancer. Right now, it's going to be me rolling solo. You guys really liked Dr. Lit. Dr. Lit will be coming back, and we will be doing a special on lupus. So keep your eyes peeled for that. But for today, it's just me. So let's delve into this study from 2018 using mice and breast cancer cells and seeing how stretching impacted the tumor's growth. What if I told you that something as simple as stretching, the thing that your gym teacher was supposed to make sure that you did before you ran that 1 mile back in middle school, might actually help slow down cancer? It sounds too good to be true, and it sounds like a clickbaity headline, which is why my headline doesn't say that. But there's actually some interesting science behind this, and today we're going to break down a 2018 study that looked at whether stretching could reduce tumor growth in mice with breast cancer. The spoiler alert, the bottom line up front, is that it worked. So let's break down what this really means. Does it mean that you should be doing yoga all day? Does it mean that the scientists said that this is repeatable, or was this a one-off? And we're going to take a look at what we still don't know. So I hope that you have something to drink, like coffee or tea, and you're in a comfortable position, because let's delve into some science. So let's start with the study. The study was published in 2018 in a journal called Scientific Reports. It was led by researchers, I'm going to butcher these names, but I'm going to try my best. Beretta, as well as Bergols, along with a team from several universities. What they did is they took mice that had breast cancer tumors. For those of you who don't know, different strands of mice, different subsets of mice can actually be infected and grow different types of cancers. So whenever you read a model or whenever you read a paper that says mice with cancer treated with this and it worked, it's important to know what type of cancer, as there are different families of cancer, right? There's different types of cancer. There's breast cancer, there's prostate cancer. It's important to know what the mice were supposed to be presenting with. In this case, it was breast cancer. So what they did is they took the mice that had these breast cancer tumors and they stretched them regularly, which is very interesting to try and picture, because it is literally about stretching the mice, gently pulling on their tissues, while other mice in the control group were not stretched at all. Now, you might be thinking, how does one stretch a mouse? And that's a very, again, like I said, a very interesting question. It's fun to kind of like mentally picture. The researchers developed a special technique where they would gently stretch the skin and the connective tissue around where the tumors were growing. And they did this consistently over a period of time. So what you do is you have the mouse has this specific area where you know the tumor is growing because you infected the mouse to have this, or not infected, but you've altered the mouse to have it presenting this way. And then over top this issue, they were going in and basically doing what sounds like soft tissue mobilization, which is like gently taking their thumb and rubbing the area around there, making sure that they're not just at skin level, but they're going a little bit deeper into the muscle and connective tissue as well. And they did this over a period of time, again, contrasting with a group of mice that did not get this at all. What they found is that the tumors in the mice that got stretched grew significantly slower than the tumors in mice that were not. And we're not talking about tumors disappearing or even shrinking. We're just talking about the rate of growing being different. But it was measurable in how fast they grew, which is significant because that has implications on how to slow down cancer growth. And it gives doctors more time to treat it and gives patients a better shot at survival. But the real question is why? Because the takeaway here is, okay, cool, stretching can slow down cancer, but it doesn't solve it. What's the point? Well, if you're dealing with a type of cancer that you need more time to treat, that you can work cooperatively with the doctors in order to target, that's something. There's also underlying implications here of, well, what is it to be said about these tissues that are growing cancers is it possible that you could even try and slow it down on the cellular level before it becomes a full-blown tumor? Um, the question is, why is stretching slowing tumor growth? And that's where the things get really interesting. Now, there's a few theories about why this might happen, and let's break down three of them. The first one is that it's all about the connective tissue. Your body has this amazing material that's called fascia, which we've talked about before. It's the collagen in the connective tissue. It's like a spider web, several layers of spider web that wraps around your muscles, your organs, and even tumors. And it's everywhere, and it likes to be hydrated, just so you know. So drinking water, one of the reasons why they say drinking water is important is it keeps your fascia hydrated, which helps with all of the tissues that it connects. Now here's the thing. Cancer loves stiff, tight, rigid environments. Imagine you're trying to plant seeds in concrete versus planting them in loose, soft soil. The concrete is rigid and supportive, and the seeds could technically take root there if the conditions are right. But the soft soil, not so much. It shifts around and it doesn't provide a firm foundation. And we're not talking about like happy soil. We're talking about very like loose, fluffy, think Dust Bowl of the 1930s. It's hard for it to take form and to take foundation. So you need a little bit of firm foundation. Too much is restrictive, too little, not enough to take root. Tumors are similar. They grow better when the tissue around them is stiff and packed tight. So when you stretch, you're loosening up that connective tissue, making it more flexible, which might make it harder for tumors to grow and spread. An interesting theory. I'm not sure if I really agree with that too much, but that's the one thought. The second theory is that better blood flow and fluid movement play a role. So when you stretch, blood flow increases to those areas. The fluids in your body move around and circulate better. And this is critically important for your, drumroll, immune system. Your immune cells are like security guards patrolling your body looking for troublemakers, specifically cancer cells, viruses, and bacteria. But if some of the venues that they're trying to navigate are clogged, it's hard for the guards to get to where they're needed. It's almost the same idea that if you have a highway throughout a country and there's a breakdown or congestion or road work, it takes longer for a higher number of those prison guards, those security guards, to get to the area where they're needed to have an effect. So the idea is that stretching might help clear those pathways, letting your immune system do its job better and thus slow the growth. Plus, better fluid movement can reduce inflammation, and cancer cells often rely on inflammation to help themselves grow. I particularly think this one's a little bit more compelling than the first one. The third one is that physical stress has an effect on cancer cells. And it's pretty straightforward. It's the idea that actual physical force of stretching might directly stress the cancer cells themselves, making it harder for them to multiply and spread. Because if you think about it, if you're a cancer cell trying to divide and grow, and suddenly your entire environment's being pulled, stretched, and things like this, it's making your job a little bit harder. Now, the current theory, as you will find with scientists, is they put forward three theories, and when you ask them which one, they'll say, well, we think it's really a combination of all three, and that's what they said here. If you ask me, the one that makes the most sense is honestly the immune response one. I think fascia plays a more important role than we realize in terms of communication, hydration, stability in the body. And when it becomes tight, and it does restrict the ability for immune cells to get where they need to go, there's something going on beyond just the immune cells themselves, probably even at the neurological or biochemical level, but at a tissue level that is impacted by stretching that we just don't understand yet, that helps the body realize there's a tumor or there's a growth, there's something else going on there that otherwise would have been lost in the noise of stiffness. It's like this idea to me that tissues that are more stiff and more rigid are constantly sending a signal to the brain saying, I'm stiff, I'm rigid, I don't feel that much, I don't move well. So it's easier for things to hide in that mass of stiff, taut muscle that's constantly sending a signal to the brain. Once you go through and you loosen up that entire tissue, the brain suddenly realizes, hey, there's something that feels off about this specific movement pattern. There's something that feels off about this specific muscle. It's not moving the same way it should. Everything else loosened up, but this is still tight. What's going on over here? And that helps the body draw attention to it. That's just my 2 cents. I have no proof of it, but that's just what my intuition says. So let's take a look at what other research says. So we looked at the stretching study. And it seems like a one-off random finding. But what's the bigger picture? We've known for a long time that exercise does directly help with cancer. There's been several studies recently that came out that said high intensity interval training specifically helps with cancer. We also know that high intensity exercise can help with Parkinson's, for example, not cancer, but just another condition that we know exercise helps with. So when you exercise, you're not just building muscle or burning calories, you're stretching and moving your connective tissue. There's been a lot of research very recently into fascia, which was the connective tissue we were talking about earlier. And scientists have now started examining it and have found that it helps, has found that keeping it healthy and flexible seems to create an environment that's less friendly to cancer cells and more conducive to general overall health. On top of that, we also have the inflammation research. Now, if you remember one of my previous videos, we talked about the connection between inflammation and fascia, which is part of what I was hinting at earlier, and why I think my brain naturally and intuitively goes there is I think there's a connection between inflammation and fascia that we just don't fully understand yet. But the inflammation research says that in order to reduce inflammation, activities like yoga and stretching have been linked to better health outcomes in a lot of areas, especially in preventing cancer. So the stretching study that we're talking about here from 2018 doesn't exist in a vacuum. It's not a one-off. It's not something that is going to suddenly steer the field in that direction. It's something that kind of exists in an environment of other research that indicates things like stretching and exercise are preventative when it comes to cancer. Taking all of these studies together, it helps fit into a larger understanding that movement, flexibility, and keeping your tissues healthy, hydrated, and mobile might help play a role in fighting cancer. But, and this is a big but, we need to talk about the limitations. First, this study was a mouse study, and mice are great for research, but they are not humans. What works in mice doesn't always work the same way in people. We have a different biology, different immune systems, a lot more different things going on. And secondly, this is still early stage research. We need more studies, bigger results, studies that include humans, and things that can say for sure that we know stretching helps fight cancer in people. And third, I cannot stress this enough, like I said earlier, this proves, at least for themselves, stretching is not a cure for cancer. If anything, it just helps slow things down to give doctors more time to examine, treat, and whatever. That was the whole intent of their paper, was this is not a treatment, this is only something that helps slow it down. So if you or someone you love has cancer, you should absolutely not go and skip any sort of medical treatment in favor for just stretching. I really got to put that in there as a disclaimer. This would be something to do alongside things like chemo, radiation, surgery, or whatever it is that you and your doctor have talked about. It's not a replacement. It's seen more as a force multiplier, an additive to help with the overall treatment of cancer. So what do we still not know? Well, first, how much stretching do you need? Notice that I didn't say anything in the study about, is it 5 minutes a day, an hour? Is there too much? We don't know. Second, what type of stretching works best? Is it yoga? Is it static stretching? Is it dynamic stretching? Does it matter? We don't know. That's future studies. Third, does this work for all types of cancers or just some? Now, breast cancer is exceedingly interesting when it comes to this because it's been proven, I think it's been proven, I'll have to double check this, that there's some evidence that stretching breast tissue or massaging breast tissue can reduce the chance of breast cancer, which means that breast cancer specifically probably responds to manual pressure and to tension different than other cancers do, which is fantastically interesting because that means different cancers respond to different stimuli. And in this case, from what I've been reading, and I have to go back and double check this, it seems that breast cancer specifically is a type of cancer that would respond well to manual stretching to inhibit its growth, or at least slow its growth a little bit, because that's what some other studies have already hinted at. Again, I don't know about the legitimacy of those studies. I haven't delved into them yet, but they are things that have popped up in like my Instagram feed and such. So there's this idea that maybe they chose breast cancer cells because they kind of already knew there's some sort of evidence out there that breast cancer specifically responds to stretching in a way that is different than, say, prostate cancer leukemia, or others. Now, finally, the biggest question is, would what they took a look at with these mice work in humans? And that's what we don't know. The good news is that the researchers are interested in finding out, and this study has opened a pathway and several different avenues for them to continue their research. And I wouldn't be surprised at all if we see this happening in human trials in the next few years. I know it's been 6 years now since that came out, but I wouldn't be surprised at all if they're trying to figure out how to do those studies. So here's my takeaways from all of this. The research is interesting. It's giving us new insights into how our bodies work, specifically with fascia. And it's something as simple as movement that might help fight disease, which is phenomenal. But we're not at the point where stretching is a proven cancer treatment. We're at the point where we're asking interesting questions about it and starting to find some fascinating, interesting answers. If you want to add more stretching to your routine, this would be a reason for me to think that I should be doing more. I should already be stretching more, but the fact that it plays a role in the fascia, possibly inflammation, and then can inhibit cell growth goes to show just how powerful stretching is and why it should be a part of your daily routine. It can help with reducing stress, easing pain, and like I said, it might even boost your immune system by getting those immune cells into where they need to go. To me, I don't see a downside. But remember, if you're dealing with cancer, you need to talk to your doctor, and you two together need to come up with a plan, and that nothing on this podcast should be medical advice for you. This is just an interesting, educational, and informative podcast on the benefits of stretching from this 2018 study. So, I hope everybody enjoyed the episode. Thank you so much for tuning in, and I hope you're inspired to do some stretches later. Please don't forget to check out 10,000. The link is in the description, and you can get, I think it's 15% off shirts, shorts, and pants, and hoodies now as well. They've been releasing a whole bunch of stuff. Also, please consider checking out the Patreon, as it helps immensely with creating these things. It allows me to be able to spend the money to buy better sound technology, microphones, you name it, even host a website where we can put all this thing to one place for you guys. We can all navigate it and grow together. So please, everybody, stay healthy, stay fit, and stay awesome. And I will catch you guys all in the next episode.